Hello and welcome back, everyone. For those of you who is joining us for the first time today, I'm Shilpa Lawande. I'll be moderating the Q&A. Thank you to all our speakers for giving us a wonderful picture of building planetary scale systems. There were four diverse talks and completely different systems solving very different problems. And it was nice to see some common patterns and some very different design choices. So without much ado, let me start our Q&A. And for the members of the audience, if you have more questions, feel free to keep adding them to the chat on the website. So Brian, let me start with you. Can you tell us a little bit about how Conveyor is able to provide as much speed as possible to its customers?
Yeah, sure. The interesting thing about Conveyor versus other deployment systems that I've used is that it's able to do a lot of parallel processing. Uh, we call it pipelining. And the way that that works is say you have like a sample pipeline where you want to build some binary. You want to test that binary and then eventually deploy it once the signal is green, essentially. Uh, the way that you can pipeline that is for some release, you're testing some commit hash, you can be building it, while another older release can be testing a different version of the binary. And yet, even another older release could be deploying some other version of that binary. So by parallelizing the kind of three stages of your deployment pipeline, we can kind of eliminate a lot of end-to-end latency there.
Great, that's fascinating. And so this must require a lot of compute and storage to manage all this. Eddy, do you have any thoughts on how you manage this? And it sounds like a very large capacity management problem as well.
Yeah, it's actually not as bad as we think. Conveyor doesn't actually provide resources towards building or deployment. We actually delegate these to other services within Meta to do. So we only hold on to references to, say, the artifacts that we produce during our deployment pipelines, and then hand them off to Twine, our cluster manager, to worry about pushing, or yeah, stuff like our CI to do testing. Conveyor itself only has to just maintain getting an artifact from one location to another. So it's actually not that bad.
Great. Switching gears, Braden, how about a question for you? So how do you handle changes in DB sharding in your system when you have to add a shard, say? How do your invalidation components handle that change?
It's relatively straightforward since the system doesn't have to care that much about what's happening with the sharding underneath the hood. So the thing that we get published to us is just what the list of shards is, and that's basically all we know. We also know how to talk to them and where they are, but not anything about what data lives where. And so when that list changes, then our only response is to make sure that we have an invalidator there that is consuming the replication stream off of that shard. And the caches also learn about it so they know which invalidators to talk to. But that's all. It's just basically propagating around a list of strings and making sure that we have enough tasks running.
And so is your invalidation system something like a pub sub system in this case between the databases and the caches?
There's a couple of different stages there. And so consuming the mutation stream from the databases does happen to involve a pub sub system for kind of implementation reasons that was easier operationally. So there is a thing that is consuming the replication stream and then dumping it into a pub sub that we consume rather than us consuming the replication stream directly. But then between the other components inside of LiveGraph, we don't have any pub sub. There's no further components. All the arrows in the diagram are just live streams. So the caches show up to the invalidators and say, hey, I'm interested in this hash range. And then stuff flows back on the stream.
Great. Sayak, switching over to your system, very interesting system, by the way. How do you balance between reactive auto scaling and over provisioning for spikes? You mentioned that you have very highly variable workload traffic patterns. How do you deal with those competing concerns?
Yeah, so Yeah, I think I'll take that. So, as we mentioned during the talk, it's a hard problem and we don't have a magic recipe for that. But usually, what has worked out for us is to look at historical data to kind of understand what are the spikes likely, what are the kind of spikes that we might be expecting, and over provisioning our resources a bit for that. Apart from that, also another aspect that is kind of that we try to leverage over here is also the SLA. So what I mean by that is the SLA that we guarantee to the customer. Say something needs to be executed in the next 10 seconds versus something that has the liberty of executing, and for which we have the liberty of executing in the next 10 minutes. For the latter, we can always lean on towards reactive auto scaling more. But for the former, where we have tighter SLAs, we would need to have some kind of over provisioning, as I mentioned. So these two have been the most useful in trying to maintain this balance. But aside from that, we are still we can still improve upon this.
Okay, great. Jack, over to you. Your org, by the way, I love the name ideas for the org, and I also loved the pictures that you had that showed all the lineage, visuals. So, given that your restatements might span multiple teams and across orgs and so on, how do you handle that problem when it crosses organizational boundaries?
Yeah, so that is actually, more heavy-handed than we would like. But, in order to facilitate that kind of decision making is precisely why that portal was built. It's basically a place where the restatement owner can get Nitro to effectively notify all the stakeholders, help and push notifications, get the approval needed, and then do the sign off. But it still requires the on-call engineers working for those different sections of the graph to be coordinated in a reasonable time frame. And that's the process that we try to keep, to get the process to scale. That has been, an open challenge.
Very good. So just going back to you, Brian, you talked about your bad package detector as one of your use cases. How do you deal with, how do you know that the diff that was identified as bad actually impacts? What's its impact radius or the blast radius?
Yeah, it's a good question.
Yeah.
Sure, sorry. It's a good question, and it's a tough problem to solve. I mentioned it in the talk that we do use our build dependency graph to do some level of kind of intelligent analysis to make sure that you're at least referencing the thing that was changed by some commit. But we don't actually know that you're using the specific code in that library that is causing the issue, right? If you have some library that has a bunch of functionality, maybe you're only using 20% of it in your actual application. So currently we don't have a great way to identify that if somebody reports an issue in a library, that you are actually impacted actively by that library. We can assert that you are using the library and using a version of the library that has the problem, but we do have a kind of a noisiness issue with the bad package detector where people will report outages and it will impact a lot of stuff potentially. And a lot of people are, will say, I don't use that section of the code, but unfortunately we just don't have a great way today to identify the way to do that. Going forward, we do have plans to allow scoping of these kinds of reported ranges where the person reporting an outage can say, this is only going to be applied to this set of services because I know it's scoped to these services, for example. So that is one idea looking to the future to kind of clamp down on the noisiness issue.
Okay, that makes sense. Let's see. Omar, maybe I'll over to you. How do you detect degradation of downstream services, like other downstream, other than the compute that you talked about?
Right. So this is actually like a quite hard problem. So first of all, it's like as we mentioned in the talk, it's extremely critical for like the async tier to be able to react to degradations to any service in the ecosystem, because for lots of services, um, a big bunch of the traffic going to them comes from the async tier. And as we mentioned, lots of the traffic on the async tier can tolerate some delay. So if we're thinking about whether to prioritize online user traffic versus traffic coming from the async tier, the user traffic always comes first. So this brings into perspective the criticality of the async tier being reactive to the problem. And one of the challenges we had in this space is one simple approach could be, depending on like the user side or like the user function, to signal that some of its downstream has been having a problem and tell us what this downstream is, and then we react based on that signal. However, we've saw that it's not always like a good idea or a reliable approach to count on the users of the async tier themselves telling us what's happening or what was the degradation that was failing in that case. So what we've did is we've worked with the major services in Meta. Most notably of them was Tau, the social graph data store. And what we've built there is a mechanism for those services to directly communicate with async tier on any degradation. And basically here we can just bypass the user side, and there's like a reliable communication between async tier and other services such that we can quickly react on those.
Yeah, I'm seeing sort of a pattern of, hard problem of detecting false positives or things of that sort in these systems. Jack, do you see that in your systems? Like, do you have sometimes have to modify your, restatements?
Yes. So we do have cases, and I didn't quite get into some of those details in the talk, but much of the data is under scope of GDPR, and which means that over time, even if there are no code changes, and the data at rest can change in order to keep up with those commitments. And so what tends to happen is when we restate, if it's a deep restatement, there could be changes that may have nothing to do with the original issue, but they may be more attributable to the changes on account of GDPR. So in many cases, that's not really a concern, but there are cases where very hard conversations have to happen if a number moves by 0.5%, because the numbers are that important. And so there's a level of judgment that the on-call engineer has to exercise, and they do have the ability to actually tweak or excuse their sections from a particular restatement. We try and do our best in order to kind of give a summary of the kind of changes or the issue at hand, and then there are cases where judgment has to be applied.
Yeah, that makes sense. Switching gears a little bit, let's talk about availability. I guess all these are planetary scale systems. I would love to hear each of your perspectives on, what availability means to you. How do you maintain availability? Braden, do you want to start?
Sure. I mean, it's obviously extremely important for LiveGraph because we're directly serving stuff to users. They need to be able to see the stuff that they're asking for. We have a little bit more flexibility with sort of the real-time nature of the system, that as updates are getting in, like if there are availability problems that we see there, that manifests as higher latency, and some amount of that is acceptable to a certain point. So we have a little bit of flexibility there, but a lot of the use of the system is just like somebody is trying to load a page and we're trying to get them results very quickly. And a lot of our techniques are the sort of standard ones, which is replicate, add more redundancy of different components. So this wasn't covered in the talk at all, but all of those components, we actually have multiple of them. We have multiple cache nodes serving the same hash range so that we can flip between them, and there's complicated pre-warming that we do between them, and we have multiple invalidators consuming and all that sort of good stuff.
Sayak or Omar, do you have any thoughts in this area? Omar, do you want to go?
Yeah, I can go. So we actually like have a good if you look at it as from the perspective of people maintaining services, like we have a good property in the system, as in it's an asynchronous platform. So if we can like make a trade-off on something, it would probably be that at a given point in time we would be okay accumulating a bunch of data under any failures, as opposed to like failing or like losing data and all these kind of irrecoverable states. However, for some latency sensitive customers on our platform, again, like the same patterns like Braden mentioned emerge. So for some of those customers, like the near real time customers, as we mentioned in the talk, we have that concept of multiple shards serving the same customer, and we actually make sure these shards are not like co-located on the same host, such that if like a host goes down, we're still able to make forward progress with other shards. And this is where like the shard coordination comes into place. We mentioned we use Shard Manager, which is also like a service created by Meta, and has like a good paper, which we referred to in the talk. So folks should feel free to check it out. Sayak, anything you'd like to add?
No, I think that covers it pretty much.
Great. Eddy, what happens if conveyor goes down? How do people build packages in that case?
Yeah, so going back to how Conveyor is an orchestration engine, basically, we contact other services or perform other actions on behalf of users to deploy our packages. But I mean, in the case that Conveyor goes down, there's always backups, as in the systems that we directly integrate with. Users can still also directly call these services. So, like for instance, if in the worst case scenario, we don't even have continuous integration anymore, and we have to build locally, users in very emergency situations can try to build packages and then deploy them using Twine or Cluster Manager if it's up directly, or by going to machines directly. Of course, that solution isn't scalable. Conveyor is solving the scalable solution, the scalability problem of having to do that every time. But emergencies can happen.
Great. Thank you. Braden, what do you think is the next scaling bottleneck for LiveGraph?
There are a few that I could see kind of coming down the pipe, and one of them is that because it's a GraphQL-ish system, the fact that the user is asking for something, or the client is asking for something on behalf of the user, that might span across a lot of different databases, right? Because we're going to traverse a lot of edges and look for a lot of stuff. We may run into some kind of elevated availability problems coming up because you're just contacting more machines, and so there's more opportunity for any of them to go wrong. And that one's got some similar solutions that we need to be able to use the redundancy that we have already in the system, which we currently can't, but we have some plans to do relatively soon. We replicate the data among the databases. Right now, we have to read from only the leader copy because there's some complicated linearization of how we see the invalidation stream versus what we find to be visible from the databases. But we've got some interesting stuff we might be able to do about that. And then there are sort of product level features that we want to add that can mark particular pieces of data as sort of non-critical. We're willing to render the rest of the UI, even if this particular thing is unavailable. We have some support for that now, but we want to strengthen that in the future.
Jack, going back to you, I think in your talk you mentioned that sometimes it takes a while for bad data to be discovered and so on. Have you thought about using like ML or any thoughts on how you might speed that process up?
So I didn't get into it, but there is an entire data quality subsystem that Nitro has that makes it very easy for pipeline owners to actually add monitors that run in line with the pipeline through the different stages. And in many cases, the places and these also include anomaly detection monitors to look at the time series and see if there's been some anomalies. But the challenges are that in some cases you're detecting shifts in the data, and shifts in the data take time. If you're looking at a monthly metric or a quarterly metric, you're not going to see that if you look at the daily data. And so that's in some cases by design. And so there's a certain class of issues where I'm not sure ML will help. But there are certainly places where smarter monitors could detect, more subtle shifts in the data. And that's an active area of exploration. The second place where I feel like ML is really promising is in actually helping us limit the scope of the restatement. So if you can make the restatement graph smaller, you can recover faster. And that's something that we've tried historically with ML, but like with generative AI, I think there's so much more potential.
Great. It was interesting that this morning's talks had a system which was using ML for investigations, and so a very analogous problem to some extent.
Yeah, in the AI ops talk, I actually caught it, and I actually sent links to my team. It was good talk.
Cool. Let's see. Maybe you have time for one more question. Sayak, can I ask you, maybe talk a bit about your flow control? How do you handle that across regions, sort of at the scale that Meta operates at?
So for handling the flow control across region, as we mentioned during the talk, we have a adaptive logic. So we kind of rely on that to figure out what is the right balance of flow that's required for the specific region. But having said that, in case if some new region comes up or we have significantly scaled up a region, then we would try to incorporate a slow start kind of mechanism where we gradually increase the flow instead of drastically introducing a lot of flow onto the downstream, because that might lead to failures. Yeah.
Great, thank you. Just to close, I was wondering if each of you might share like the biggest lesson you might have learned from building your system. Omar, do you want to start? Like just one takeaway from
Yeah, sure. So I think for me the biggest takeaway is always starting from like SLAs, or at least like aspirational kind of SLAs, like what do we really need versus what do we like want, or because like we engineers like try to always do the best possible, like the most performant, the cheapest, all these kind of things. However, I think we sometimes have some leeway to take some informed trade-offs when we speak to customers. And this really helps in setting the right environment of, easier operations, less complexity, all these kind of good things which come from less intertwined systems. So I think that was the biggest learning for me in this scaling journey.
Braden?
Sure. I can't speak for the teams as much, but for me, myself, my background before working on LiveGraph was in databases and file systems and things where there's lots of very hard state. Things are extremely durable and we keep absolutely everything. And LiveGraph is a system with quite a bit of sort of interesting, hairy correctness guarantees that have to be upheld, but all the state is very soft. And that brought quite a number of unexpected challenges.
How about you, Jack? Any
Yeah,
lessons?
so for us, I think at least for me, the biggest learning was around how under-understood, if I want to use that term, like how poorly understood um, the complexity of some of these lineage graphs that exist in companies are. Like, at least when we were beginning rendering this graph, or even trying to explain what this graph looks like, convincing people that, there really are so many points of contact as data flows through layers through different parts of the org. That was not a very well understood thing. And then building up an engineering system that can manage the life cycle of something like that. All in all, I think that was, a path that we had to walk, and take a whole bunch of our stakeholders along the way. That this thing exists, it's a problem, and it has to be dealt with.
Great. Well, looks like we're out of time. Thank you again, everyone, for a very engaging conversation. And I will hand over back to. I believe we have a small break, and then we will resume again the session number 3. Thanks again to all of you, and it was a great conversation.